so we proceed with question 3. Question 3 A. This is question 3A 1. Okay. So the question for question 3A1 reads, differentiate the following functions with respect to x. We differentiate with respect to x. We have 4 in 5y. Okay, so how do you differentiate 4 in 5y? Here we have two parts that we have, the 4 and the in 5y. So how are we going to solve this? These are implicit functions. Implicit functions. Okay, so how do you solve this one? So remember the term we're using, a function of function, whereby we'll have dy dx is equals to dy dx is equals to dy du times du dx. Okay, this is what we call function of function. So function of function together with the implicit function is what we're going to apply for us to solve this one. So the first thing that we have to do is, since this is the formula for function of function, and the question says differentiate the following functions with respect to x. So whatever we're going to be differentiating to, we have to be differentiating is to with what? With respect to x. The implicit function, we are going to have our dy, we are going to have our du dx, because everything will have to be differentiating it with respect to x. Du dx is equals to du dy multiplied by dy dx. So this one will be our implicit function. So whereby we have this our 4. So we'll say our 4 in y. So we say let u equals to 4 in 5y. Okay. So let our u equals to 4 in 5y. So du dx is equal to, what is our du dy? So we have this one. So while there is u here, we are going to substitute with what? With this one. It's just part of the expression which you are substituting. You're not substituting everything. That's where the implicit function is coming from. Just substitute part of the expression, not everything. So where there is, we are going to have our d here, open bracket, d over dy, open bracket. What is our u? Our u will have 4 in what? In 5y, you close, you multiply it by dy dx. Remember, our question says that everything is supposed to be differentiating according, supposed to be differentiating with what? With respect to what? To x. So since we have to be differentiating this with respect to x, 4 in 5y, let's differentiate this then. How do you differentiate this? So our final answer here, if we differentiate this, if you differentiate 4 in y, if you differentiate in y, if you differentiate in 5y, you're going to have 1 over what? 1 over 5. But it's not 1, or you're going to have 1 over 5. But here you have this number. This number here is not counted, the 5, it's not counted. So it will be 1 over y. But if you have a number here like 2, so this one becomes a multiplier. It will be here. So it will be 2 over y. Same applies to this one. If you differentiate 4 in 5y, don't count the 5 here. It's just going to be, since we have this and we differentiate this, so you're going to have 4 over y divided dx. So this one becomes the final answer. Simple as that. So that's how we differentiate. Okay. It's simple. The implicit functions are simple. So you just have to follow. As long as you know how to differentiate, then everything's going to be simple for you. Let's move to the second question. Question 2. Okay. So question 2, the question reads, this is question 2. Okay. So question 2, we have 1 over 5. 1 over 5 e raised to power 3 theta minus 2. Okay, even this one we have to differentiate with respect to what? With respect to x. How do you differentiate this one with respect to x? The same thing. du dx is equals to du dy dx with respect to x. Where are we supposed to substitute this? Here. That's where it's supposed to be substituted. Simple. So it will be my d over dy, open bracket, I substitute 1 over 5, a raised to power 3 theta minus 2. I close bracket, I multiply everything by what? Dy dx. When you reach this stage, what are you supposed to do? I differentiate this in the bracket. These are natural logs, so how do you differentiate this? You sort out first this part here. How do you sort out this part? What is 3 theta minus 2? If you differentiate 3 theta minus 2, I'm going to have a 3. So this one doesn't, it's not affected in any way. So I differentiate this, then the answer I'm going to get for this part, I multiply with what is down there. So it will be 3 theta minus 2. If I differentiate 3 theta minus 2, I'm going to have a 3, because this one is what's this, a constant number. So if you differentiate a constant number, it's always a 0. This is 3 theta. If I differentiate 3 theta, I'm going to have a 3. So if you differentiate 3 theta minus 2, I'm going to have a 3. 3 times 1 over 5e, I'm going to have 3 over 5e raised to power the whole of this. So this one becomes my answer, the final. So it will be 3 over 5e raised to power 3 theta minus 2 dy dx becomes my answer. Differentiating it with what? With respect to x. But this one has been differentiated with respect to x. But this one has been, so here it was supposed to be, so it was supposed to be d theta. So d theta, yeah, it was supposed to be d theta here, because we have a theta in our question, so it's supposed to be d theta instead of dx, but d theta. Yeah, so this was an error for the guys who prepared this paper. So it's supposed to be d theta over dy. Yeah, d theta over dy is multiplied by dy over dx. This is how it's supposed to come out. So this one becomes your answer. Fine. We proceed to question B. Question B, it's use logarithmic differentiation to differentiate y. Okay. Hope you are following. If you don't understand any of these, please try to leave a comment in the comment section. Okay, so B, this is where the math is now. So 3B, the question reads, use logarithmic differentiation to differentiate y equals to y equals to open bracket x plus 1 open bracket x minus 2 raised to power 3 over x minus 3. Okay, how do you differentiate that question? How do you differentiate that question? Okay, so for me to differentiate this question here, the first thing that I have to do, since they have said that these are the logarithmic differentiation, I'll introduce the in for this. So I'll say, let me introduce first the in y equals to, I'll have something like this. Okay, x plus 1 x minus 2 raised to power 3 over x minus 3. Okay. If I reach this stage, what next? What's next? Let me try to get another marker. Okay, what next? Okay, so what next am I supposed to do? Since I have this thing, let me try to remove these brackets which I have included here. So I'm going to have my in y, which is equal to this one. If I multiply everything in the bracket, it will be in open bracket x plus 1, I close open bracket. So now here the sign, what sign am I going to include here? So the rules of logs, that tells us to say, if you are multiplying, meaning here in between there what? There's a positive. If you are dividing, in between it there's what? There's a negative. So here I'm going to have a plus in this one, open bracket x minus 2 raised to power 3, divide, which is a negative, in open bracket x minus 3. Okay, if I reach this stage, what next am I supposed to do? Okay, I'll try to drop these powers here. So I'll go with the same strategy. In y equals to in open bracket x plus 1 I close plus this bracket, this power here has to drop, so I'm going to have a 3 in open bracket x minus 2 minus in open bracket x minus 3. Don't forget the rules of indices because they are going to help you understand the logarithmic differentiation. If you reach this stage, what are you supposed to do? Differentiate with what? With respect to x. So how am I going to differentiate this with respect to x? Simple. This is how we differentiate it with respect to x. If I differentiate in y, I'm going to have my 1 over 1 dy dx. I'm differentiating it with respect to x, which is equal to, if I differentiate this one in x plus 1, I'm going to have 1 over what? X plus 1. X plus 1 plus, if I differentiate in this one, I'm going to have a 3 over x minus 2 minus, if I differentiate this one, I'm going to have 1 over x minus 3. Hope you know how to differentiate the ln x. So if you have 3 in 5y, this one is same as, this one is same applies as in 3 over y. This is how we differentiate. If you have something like, I want to differentiate, let me say, in x plus 2. This is just 1 over x plus 2. This is how we differentiate. Okay, so since I have this, what am I supposed to do? Let me try to rearrange everything nicely. Okay, so since I have this one, so here I'm going to remain with my dy dx, which is equal to this one. I'm going to have my y, to get everything this one the way it is. I'm going to have my y, open bracket, 1 over x plus 1 plus 3 over x minus 2 minus 1 over x minus 3. Okay, so now y, it's what? It's this. So now I substitute everything by what? By this. So I'll say here dy dx, which is equal to, what is my y? It's x plus 1 in bracket, open bracket, x minus 2 raised to power 3 over x minus 3. Then now here, this, I get everything 1 over x plus 1 plus 3 over x minus 2 minus 1 over x minus 3. So this one becomes my final answer. Question 3 is done. Have you seen that? Engineering mathematics 2 is so simple. So this one is done. You proceed to question 4. You proceed to question 4. So this one is done. So just for you solving this, you get your 10 marks. Solving A1, 5 and A2, 5. Together you get your 20 marks.